Unit 1, Planet Earth. Chapter 1, The Physical Earth. Getting started. Listening to directions. Page 4. Look at the diagram. There is a large circle on the left. It is labeled Earth. There is another smaller circle on the right. This circle is labeled Mars. Next to the circle on the left, write about some of Earth's features. Next to the circle on the right, write about the features of Mars. It's all right to use single words or simple phrases. You don't have to write complete sentences. In the middle part of the diagram, under where the two circles overlap, write about the features that Earth and Mars have in common. Interview 1. A geologist talks. Listening for main ideas in an interview. Page 7.
Brad, you're a geologist. Can you define geology for me?
Well, the simplest way to define geology is the study of rocks, but there's a little more to it than that. It's really the study of the composition and dynamics of Earth, from its center to its surface.
The composition and dynamics of Earth. Okay, so composition is like what Earth is composed of or made up of, right?
Right, and dynamics refers to Earth's movement. So geologists study what Earth is made up of and how it moves.
How did you become interested in geology?
I guess I've always had all these questions about Earth. Like, the first time I saw the Rocky Mountains, these huge mountains, I had so many questions in my head. How could these mountains be here? What caused this? And when we had an earthquake in California, I asked, why is Earth shaking? When I was growing up, I was always interested in beaches. How do beaches get their shape, and why do they change? So I've always been really interested in why things look the way they do. And I've always wanted to know why things change on our planet.
It sounds like from a young age you had questions about Earth. So it sounds like geology is a very good career for you.
Yes, I enjoy studying geology, and I love my work.
What are you working on right now?
Now we go to beaches and measure the size and shape of each beach. We measure the size and shape at different seasons and from year to year. Then we see if the beaches are changing shape over time.
And have you found that the shape of the beaches is changing?
There's definitely change. The shape of the beaches changes every year between the winter and summer months, but what we're really looking for is a long-term erosion problem.
Long-term erosion. Does that mean the beaches are eroding more and more over time?
That's right. If the beaches don't come back year after year, that's not a temporary change, it's a trend. In other words, the beaches are eroding.
So, Brad, tell me, why should people care about geology?
First of all, it's just a lot of fun. You get to work outdoors. But second of all, it's important to our society. Humans are having a big effect on our planet, and it's important to understand what we're doing to Earth. So people should be excited about geology because it's fun and because it's important for our future.
Interview 2. Earth's Natural Beauty. Listening for details. Page 8.
So, Gabby, you've been to the Grand Canyon 2 times?
Yes, the first time I went to the Grand Canyon, I went hiking and camping there. The second time, I got to ride in a helicopter and fly down into the canyon.
The Grand Canyon is a very popular place to visit in America, right?
Definitely. I think the Grand Canyon is America's most famous natural landmark.
What does it look like?
Well, it's really, really big. When you stand there looking at it, it seems to go on forever. And there are cliffs that are all different colors, like red and blue, purple and orange, yellow and brown. It almost looks like a painter came and just painted the sides of the canyon with all these different colors.
I'm surprised to hear that. I thought it wouldn't have much color since it's formed out of rock.
I thought so too, but the cool thing is The colors of the rocks are so different, and when the sun moves, it changes the colors of the canyon walls. So if you stand there for an hour, you can see the light changing as it moves across the rocks.
Interesting. So the changing light makes the rocks look different?
Yes, the same area looks totally different when the light changes.
It sounds beautiful.
It is. A lot of people say that when they see the Grand Canyon for the first time, it brings tears to their eyes.
Oh, you mean it makes them cry?
Because it's so beautiful, they almost cry, yes.
Did you cry when you first saw the Grand Canyon?
Well, I remember thinking, this is one of the most beautiful things I've ever seen, and I remember feeling very lucky to be seeing it.
Do you know how the Grand Canyon was formed?
I think most of it was formed by water. A large river goes through the floor of the Grand Canyon. So basically, I think the river eroded the rock over millions of years and formed the canyon.
So, Jane, tell me about a famous natural landmark in Australia.
Right. Uluru is a very famous landmark in my country and one of the most visited sites in Australia.
Uluru. That's hard to pronounce. Uluru. Is it a mountain?
It's a massive red rock in the centre of Australia. I've heard that Uluru means island mountain. It's also called Ayers Rock.
So it used to be a mountain in the past.
Yeah. Well, millions of years ago, layers of rock were lifted out of the earth. Then over time, the softer rocks eroded away and Uluru is what's left. It's made up of very, very hard minerals. We believe it's more than 300 million years old.
300 million years old? Incredible.
Australia is a very special place. We're the oldest continent, we're also the flattest, and Australia is the driest continent where people can live.
I didn't realize that Australia had so many unique features.
We have a lot of unique and stunning natural places.
Jane, what does Uluru look like?
It's beautiful. It's a large red rock in the middle of a very flat area of land. If you look at it from far away, it looks smooth. But if you move closer to the rock, you can see that it has holes in it and is really quite rough.
Really? And what color is it?
Well, the surface is reddish-brown, but the colour can change depending on the time of day. I've seen it look pink, purple, and sometimes grey. When the sun hits it, it looks like it's glowing.
Lecture. Laura Barbieri. A look inside planet Earth. Before the lecture. Listening for main ideas in a lecture. Page 11. Lecture topic.
Today, let's look inside the planet Earth and discuss its internal structure.
First main idea.
But first, I want to give you some background information about our planet.
Second main idea.
Now I'd like to discuss each of the three main layers of Earth. First, the crust. There are two kinds of crust, oceanic and continental.
Third main idea.
Moving down from the crust, the next layer of Earth is called the mantle.
Fourth main idea.
Finally, continuing downward to the center of the planet, we come to the core. The core can be divided into two parts, an outer core and an inner core.
Lecture. Part 1. Planet Earth. Background. Listening for supporting details. Page 14.
When you think of the planet Earth, what do you think of? Probably the many natural features that you can see on Earth. For example, you probably think of mountains, forests, deserts, oceans, rivers and lakes, soil and rocks. All of these are important features on the surface of the Earth. But have you ever thought about what's below Earth's surface? Today, let's look inside the planet Earth and discuss its internal structure. But first, I want to give you some background information about our planet. As you know, there are 8 planets in our solar system. Our planet Earth is the 3rd planet from the Sun. It is also the 5th largest planet in our solar system. How large is Earth? If we draw a line directly through the center of the planet, the distance from the North Pole to the South Pole is almost 13,000 kilometers. Earth is made up of 3 main layers: the crust, the mantle, and the core. The crust is the outer layer of Earth. The mantle is the next layer under the crust. The core is the last layer at the center of Earth. Scientists can study these 3 layers by using seismic waves. Seismic waves are like waves of energy. Scientists send these waves of energy through the crust, the mantle, and the core, and watch carefully as the waves pass through the 3 layers. Seismic waves act differently as they pass through different kinds of materials, so scientists can learn important information about Earth's layers.
Lecture, Part 2. Inside Our Planet. Listening for supporting details. Page 16.
Now I'd like to discuss each of the 3 main layers of Earth. First, the crust. Earth's crust is what we see when we look at Earth's surface. If you imagine that Earth is a piece of fruit, the crust is like the skin of the fruit. Our planet's skin is made up of solid rock. There are 2 kinds of crust: oceanic and continental. Oceanic crust is all of the crust that is covered by Earth's oceans. Actually, most of Earth's crust is oceanic because most of Earth's surface is covered with water. Continental crust is the part of the crust that makes up Earth's land areas. Which do you think is thicker, oceanic crust or continental crust? If you guessed continental crust, you're correct. Oceanic crust is only about 6 to 11 kilometers thick. Continental crust is thicker than oceanic crust, about 30 to 40 kilometers thick. And as I said, both kinds of crust are made up of solid rock. Moving down from the crust, the next layer of Earth is called the mantle. This layer is much thicker than the crust. The mantle is about 2,900 kilometers deep. The upper part of the mantle is cool, solid rock, like the crust. But the further down you go into the mantle, the more the temperature increases. Because of the higher temperature, the lower part of the mantle is hot and soft. Finally, continuing downward to the center of the planet, we come to the core. The core can be divided into 2 parts, an outer core and an inner core. The outer core is very, very hot. It is so hot, in fact, that the rocks here melt and become liquid. Think about that. Deep down below us, near the center of the Earth, there is a layer of hot, liquid rock. At the very center of Earth, there is a huge ball of very high pressure and high temperature material. This is called the inner core. Scientists believe the inner core is made up of 2 metals called iron and nickel. The pressure of Earth on this iron and nickel creates a lot of heat. Scientists guess that the temperature of the inner core may be as high as 4,000 degrees Celsius. This heat moves outward from the core and heats the planet from the inside.
Unit 1. Planet Earth. Chapter 2. The Dynamic Earth. Getting started. Listening for numerical information about distances and rates. Page 19.
Earth's surface is broken into large pieces called plates. These plates are slowly moving all the time. For example, the 2 large plates under the Atlantic Ocean are moving away from each other. Scientists have measured the rate of movement at about 2.5 centimeters per year. In other words, the Atlantic Ocean is slowly growing bigger, by about 2.5 centimeters every year.
The Himalaya Mountains began to form when 2 plates pushed together 50 million years ago. As the 2 plates came together, the land was pushed up and formed mountains. Today, the plates are still moving toward each other, and the Himalayas are rising at a rate of about 5 millimeters per year.
Sometimes two plates move past each other side by side. One example of this is in the state of California. The southern part of California is moving northwest, while the northern part of California is moving southeast. The rate of movement is almost 5 centimeters a year. In theory, San Francisco and Los Angeles could move past each other in the future.
The Hawaiian Islands are located in the middle of the Pacific Ocean. The islands are moving in a northwest direction at a rate of about 7 centimeters per year. As they move northwest, they are getting closer and closer to the islands of Japan. In theory, the two groups of islands may meet millions of years in the future.
Interview 1. Living near an active volcano. Understanding multiple choice questions. Page 22.
Lauren, you live on the Big Island of Hawaii, one of the most dynamic places on Earth.
I think the Big Island is the most dynamic place on Earth. At least, we have the world's most active volcano.
That sounds interesting. Can you tell me more about your volcano?
Well, the volcano's name is Kilauea. It is called the world's most active volcano because it has been erupting continuously since 1983. That means it has been erupting for 30 years.
What's it like living near an active volcano?
It's exciting. I never get tired of watching Kilauea erupt. In the mid-'80s, I was working at a school close to the volcano. I will never forget standing on the second floor of the building and seeing a huge fountain of lava shooting up into the air.
You could see a fountain of lava from your school?
Yes, hot, liquid rock shooting straight up in the air. It was just spectacular. And the sound was so loud. Volcanoes make a very loud sound when they erupt. It was like a plane taking off at an airport. It was awesome.
That does sound awesome.
And I felt very lucky to see an active volcano since not many people in the world have that opportunity.
And Kilauea is still active today?
Yes, it is still erupting today. But the lava often flows underground. Sometimes you can see the bright orange lava flowing toward the ocean. When the hot lava meets the ocean, it creates a large cloud of steam.
It's probably dangerous, but I would really like to see that.
Yeah, when there's an eruption, people do want to go see it. But the volcanoes in Hawaii usually do not explode strongly or suddenly. People hurry to see active lava, of course, from a distance. It's beautiful.
I guess what they're seeing is new land that is forming on Earth. That lava becomes the newest land on our planet.
Yes, new land is forming all the time. And scientists are watching Loihi, which is a volcano in the ocean next to the Big Island. Loihi hasn't come to the surface yet. Someday, it'll be the newest Hawaiian island.
Interview 2. Living with earthquakes. Drawing inferences. Page 24.
Zach, you grew up in San Francisco, is that right?
Yes, that's right.
And Yoshiko, you grew up in Tokyo?
Yes, I'm from Tokyo, Japan.
And now you both live in San Francisco, right?
Right.
So you've both had a lot of experiences with earthquakes. Could you tell me about them?
Well, most earthquakes are very small, so usually you don't even know they've happened. Many earthquakes happen when I'm asleep and I don't even notice.
You probably keep sleeping during the small earthquakes.
Yeah, I just keep sleeping because I don't feel anything. And then there are small ones that happen very quickly and I think, oh, was that an earthquake? It just feels like a little shaking, so I'm not sure if it's an earthquake or not.
Have you ever felt a really strong earthquake?
The biggest one I felt, I was at work in my office. It was a tall building and there was a very strong earthquake. It felt like the floor became liquid, like there was a wave going through the room. And the corners of the office were going up and down like ocean waves.
Yoshiko, have you had similar experiences in Japan?
Oh, yes. I don't remember every earthquake we've had in Japan, but most of the ones I felt were when I was at home.
Oh, really?
Yes, because if you're outside walking or driving, you're not going to notice an earthquake unless it's a big one. But in my house, everything starts shaking and making noise. I hear the noise first, and then I know an earthquake is starting.
Aren't you both afraid when an earthquake happens?
Like I said, most earthquakes are so small that it's no big deal. I mean, no one really notices them or worries about them. When you grow up in an area like San Francisco or Tokyo, areas with a lot of earthquakes, then it's just a part of life. You get training in school, and hopefully you remember what to do if there's real danger.
You get training in school? What kind of training?
Well, in school we had earthquake drills, just like you have fire drills to prepare for a fire. We practice what we would do in case there is a real earthquake. Students get under their desks, and the teacher gets in the doorway.
In Japan, when an earthquake starts, everybody starts opening doors.
I see. Why do you open the doors?
So later, after the earthquake, we'll be able to go outside. And we know we should go under a desk or a table or in the bathroom. Also, we talk with our family and decide where we should go after an earthquake. Usually it's in the park or the school or some other open space.
So you make an emergency plan.
Right, because you need to know what to do if you're separated from your family. If you make an emergency plan, you know where to meet your family after the earthquake.
What are other things you do to prepare for an earthquake?
We try to keep extra water at home.
Water is the number one thing. And then food is number two. Let's see, what else? A flashlight, extra batteries, a radio, extra blankets.
So, living in San Francisco, you're not afraid that the big one might be coming soon?
I think earthquakes are amazing. When you imagine how powerful that energy is, powerful enough to shake a huge amount of space and land. But I love San Francisco, and San Francisco has earthquakes, and so it's just part of life. You can't be afraid. I mean, you just have to live your life.
Lecture. Patricia Fryer. Volcanoes. Before the lecture. Focusing on the introduction. Page 30.
Today's lecture is going to be about volcanoes. I love volcanoes. I have loved volcanoes my whole life, ever since I was very young and I saw the volcano Kilauea in Hawaii. I didn't know it then, but I learned later that volcanoes make about 75% of all the rocks on the surface of Earth. When you look around and see rocks, remember that most of those rocks, 75% of them, come from volcanoes. So volcanoes are a really important topic when we talk about our natural world. I'd like to start today's lecture by introducing the basic structure of a volcano. In other words, the different parts that every volcano has. Then I'll describe three basic types of volcanoes: shield volcanoes, composite volcanoes, and supervolcanoes. For each basic type, I will also give you an example. Finally, we'll discuss some of the signs that volcanoes exhibit right before they are going to erupt. These are signs in the area around a volcano that scientists can look for that warn that an eruption is about to happen. So let's get started.
Lecture. Part 1. The basic structure of a volcano. Using telegraphic language. Page 32.
Today's lecture is going to be about volcanoes. I love volcanoes. I have loved volcanoes my whole life, ever since I was very young and I saw the volcano Kilauea in Hawaii. I didn't know it then, but I learned later that volcanoes make about 75% of all the rocks on the surface of Earth. When you look around and see rocks, remember that most of those rocks, 75% of them, come from volcanoes. So volcanoes are a really important topic when we talk about our natural world. I'd like to start today's lecture by introducing the basic structure of a volcano. In other words, the different parts that every volcano has. Then I'll describe 3 basic types of volcanoes: shield volcanoes, composite volcanoes, and supervolcanoes. For each basic type, I will also give you an example. Finally, we'll discuss some of the signs that volcanoes exhibit right before they are going to erupt. These are signs in the area around a volcano that scientists can look for that warn that an eruption is about to happen. So let's get started. First, the basic structure of a volcano. Well, volcanoes are formed by hot melted rock called magma. Magma comes from the Earth's mantle, which is a layer deep below Earth's surface. The upper mantle is from 80 to 150 kilometers below Earth's surface, and the temperatures here are so high that rocks start to melt and become magma. This magma flows through the mantle and pushes up against the solid rock above. Usually an eruption starts because an earthquake breaks the rock at the top of the mantle and creates an opening. The magma then rises through the opening in the solid rock and moves towards the surface of the Earth. Finally, the magma comes out of the opening in the crust, called a vent. Now, when magma flows onto the Earth's surface, we don't call it magma anymore, we call it lava. So melted rock under the Earth's surface is called magma, but melted rock on top of the Earth's surface is called lava. You probably think of a volcanic eruption as a big, loud explosion, right? But a volcano can erupt gently as lava that flows along the surface of the Earth. Of course, a volcano can also erupt very powerfully, too. A powerful eruption can have clouds of ash and rock that rise thousands of meters into the sky.
Lecture, Part 2, Types of Volcanoes. Using telegraphic language, page 35.
All right, now let's take a look at some of the different types of volcanoes. There are many different types of volcanoes, but today I will tell you about 3 basic types. The first kind of volcano is what we call a shield volcano. A shield volcano is usually very, very big. Lava flows out from its vent in gentle eruptions. The lava comes out of the vent gently and then flows along the surface of the Earth. The lava cools and becomes hard, forming a broad circular shape. The shape kind of looks like a shield, broad and circular, with sloping sides, which is why these volcanoes are called shield volcanoes. An example of a shield volcano is Mauna Loa in Hawaii. It's the largest volcano on Earth. Mauna Loa starts on the seafloor and rises to over 9,000 meters. Another type of volcano is the composite volcano. Composite volcanoes are smaller than shield volcanoes. The tallest composite volcanoes are only about 2,500 meters high. Composite volcanoes have both explosive and gentle eruptions. Often the volcano will start with an explosive eruption and layers of ash and rock will pile up near the vent. Then a gentle eruption happens. The lava flows out and covers the layers of ash from the first eruption, making a cone that has alternating layers of ash and lava. Do you know the meaning of composite? It means made up of different parts. Composite volcanoes get their name because they are made up of different layers of ash and lava. A good example of a composite volcano is Mount Fuji in Japan. Another example is Mount St. Helens, which erupted in 1981. The last type of volcano I'd like to talk about today is a supervolcano. Supervolcanoes are the biggest volcanoes and have the most explosive eruptions. They don't form a cone shape at all. Instead, they leave a huge crater or hole in the ground. Eruptions from supervolcanoes don't happen very often, but when a supervolcano erupts, it causes widespread destruction that affects all life on Earth. Scientists believe that the largest supervolcano was Toba. It erupted about 70 to 75,000 years ago in Indonesia. Some scientists think that the Toba supervolcano killed at least 60% of all people on Earth. Pretty scary. But most volcanoes give some signs before they actually erupt, and today scientists are very good at noticing these signs before the eruptions. Some examples of warning signs are earthquakes and ground cracks. Another sign is when drinking water tastes different. Changes in the earth sometimes affect the way water tastes, so this could be a sign that a volcano will erupt soon. Sometimes ice at the tops of volcanoes starts to melt. Volcanologists who study active volcanoes notice the melting ice and all of the other warning signs and can help in planning for and escaping from dangerous situations.
Unit 2. Water on Earth. Chapter 3. Earth's Water Supply. Getting started. Building background vocabulary. Page 45. 1. Two. 3. 4. 5. 6. 1. Water in the United States. Listening for opinions. Page 48.
So, Gina, we're here to talk about water. Americans are lucky that we don't have to worry about access to water. By that, I mean we can get fresh, clean water anytime we want.
Oh, yeah, I totally agree. I have traveled to places in the world where you can't drink the tap water. In fact, you can't even get tap water on your toothbrush.
Is that because the tap water isn't safe to drink?
That's right. You always have to boil it or use water from a bottle. And the first thing I do when I get back to the United States is go pour a glass of water from the tap.
And you really enjoy it.
Yeah, something like that. It just feels so clean. Like you said, Americans are very lucky. We can just turn on the tap.
Even though we can drink tap water in the United States, there are a lot of people who are worried about our water. For example, some people think that there are pollutants in their drinking water. Is that something you're worried about?
Well, sure. I mean, just about everywhere you go in this country, there's been some sort of pollution that affects the drinking water. However, I believe that the people who are in charge of the water supply are checking it carefully, and they know if the water is safe to drink.
So you trust that somebody is checking your water supply and making sure it is clean and safe to drink?
Yes. I mean, I know that there are some places where it may not be safe, but I feel like I'm lucky because the water where I live seems to be really clean and good to drink.
So you don't drink bottled water or anything like that?
No, I'm happy with our tap water. I buy bottled water sometimes, but mostly for the convenience of having bottles to take in the car. If I buy bottled water, I try to reuse the bottles most of the time.
It's probably a good thing that you don't drink a lot of bottled water, because actually many people think bottled water hurts the environment.
Because of its packaging, right? All those millions of plastic bottles that we drink every day are quickly filling up our landfills. The way I see it, if we could stop using all those plastic bottles, that would help our environment.
Interview 2. Water in Cambodia. Listening for details. Page 49.
Laura and David, you lived in Cambodia?
Yeah, we lived in Cambodia for almost 4.5 years. Part of the time we were living in Phnom Penh, the capital. It's a very large, growing city. The other part of the time we lived in the countryside.
I want to talk about the water supply. When you were in Cambodia, did you have any problems getting clean water?
Well, when we were in Phnom Penh, people would have to buy water from trucks.
So, in the capital city, people didn't have running water in their homes?
That's right. When we lived there, many people in the city collected and drank rainwater. Or they bought water and boiled it at home.
But I think Phnom Penh is better now. The government is trying to provide running water for all the people who live in the city.
Now, you said you also lived in the country. Was access to water better there?
No.
Cambodia has some of the worst problems in the world with water. Thousands of children die from waterborne illnesses every year there.
So they get sick from drinking the water, and they can die from drinking it?
People drink mostly surface water, which means whatever water they can find. In the countryside, people didn't have enough money to buy wood to boil the water, so they would just drink surface water and get sick.
And people get sick because the surface water contains
feces.
Feces of cows, birds, and other animals. It all goes into the ponds where people wash their cows, and then they drink the water.
People don't know that if they drink the water, they'll get sick?
Well, they know they should boil the water, and sometimes if they have extra wood, they boil it. But they also need the wood to cook their food. So if they can't buy enough wood, they choose to not boil the water.
So what about you? What did you drink?
We tried to bring bottled water with us all the time. If we were out and had to drink their water, we would ask them to boil it first. But it was still not very nice. It was very thick, sort of a tea color, because it's just what you would take out of a river or a pond.
Interview 3. Water in Cameroon. Listening for specific information. Page 50.
Shauna, you lived in Africa. Where did you live and how long were you there?
I lived in Cameroon in West Africa. I lived there for just over a year.
Did you have any trouble getting clean, safe water?
A lot. I was very careful about water because I had been told you could get sick. So I tried to make sure to boil it or buy bottled water.
Did you ever get sick from the water in Cameroon?
No, I never had a problem, so I became more relaxed. I sort of just watched what other people did, and I did what they did. That's what made sense to me. Because if they weren't getting sick, then I didn't think that I would get sick.
That does make sense.
But I can tell you one story about access to water. You know, some parts of Cameroon have really good roads and everyone has water.
Okay.
But in this other area that I went to, which is very difficult to get to because the roads are terrible, people would travel like sometimes 10 miles to get water. It's just heartbreaking because they had to travel so far just to have water.
Was that because this was a poor area?
Yes. And it's sort of like how people have access to things in the United States. You know, in a poor neighborhood, people do not have the same things as they would in a rich neighborhood.
But water is something that you need to survive. People have to have water every day.
Exactly. In Cameroon, I would see women carrying huge buckets of water on their heads, you know? So what I noticed in Cameroon is that people work very, very hard, and they are able to survive under difficult conditions.
Are people less wasteful of water because of how hard they have to work to get it?
I think people are less wasteful because they have to be. I think that's a natural response to, you know, this is how much water I have in front of me.
Did living in Cameroon change you and the way you think about water?
Yeah, sure. Because seeing someone walk 10 miles to get a bucket of water, and she has 3 small children following her, it's just heartbreaking.
I'm sure you'll never forget what you saw in Cameroon.
Yeah, and so when I turn on my tap, I'm thinking about the people in Cameroon. That affects how I use water and how I think of water in the world. You know, water connects all people. The ocean touches every continent, right?
Right.
Water comes from Earth and flows across Earth. It's like blood. In some cultures, water is seen as the blood of Earth. I think of it that way. The Earth is like a living thing. All the plants and animals are parts of the Earth's body, and everything is connected by water. To me, water is a metaphor for life.
Listening for specific information. Page 50.
Water comes from Earth and flows across Earth. It's like blood. In some cultures, water is seen as the blood of Earth. I think of it that way. The Earth is like a living thing. All the plants and animals are parts of the Earth's body, and everything is connected by water. To me, water is a metaphor for life.
Lecture. Martha McDaniel. Sources and Functions of Surface Water. Before the lecture. Using Symbols and Abbreviations. Page 55. 1.
Anyone who has ever been to the ocean or seen a picture of our planet taken from space knows that there's plenty of water on Earth. In fact, most of the Earth's surface is covered in water.
2.
However, almost all of that water is salt water. In fact, 97% of the water on Earth is salt water. That means only 3% of the water on Earth is fresh water.
3.
Only 3% of the water on Earth is fresh water. But of that 3%, almost 75% is in the form of ice in the coldest parts of our planet. That means that only about 25% of the fresh water on Earth is in liquid form.
4.
This small percentage, less than 1% of all the water on Earth, provides drinking water for every person on Earth as well as for its plants and animals.
Lecture. Part 1. Sources of Fresh Water. Using Symbols and Abbreviations. Page 57.
Anyone who has ever been to the ocean or seen a picture of our planet taken from space knows that there's plenty of water on Earth. In fact, most of the Earth's surface is covered in water. However, almost all of that water is salt water. In fact, 97% of the water on Earth is salt water. That means only 3% of the water on Earth is fresh water. That doesn't seem like very much fresh water for people to use and drink, does it? But wait, the amount we can use is even less than that. As I said, only 3% of the water on Earth is fresh water. But of that 3%, almost 75% is in the form of ice in the coldest parts of our planet. That means that only about 25% of the fresh water on Earth is in liquid form. This small percentage, less than 1% of all the water on Earth, provides drinking water for every person on Earth as well as for its plants and animals. Now that's amazing. Today I will talk about this amazing precious resource, Earth's fresh water supply. Where does fresh water come from? When rain or snow falls from the sky, much of the water sinks into the ground and becomes groundwater. But if the water can't enter the ground, or if the ground is already full of water, then the water stays on the surface. This water starts to move over the surface, and as it flows, it cuts a path into the land. Over time, the path becomes deeper. Now that flow of water is called a stream. Streams are small, but if they combine or come together with other streams and become bigger, then we can call it a river. Sometimes streams and rivers stop flowing and form a pond or lake. Other times, water keeps flowing across the land until it reaches the ocean. Of course, fresh water is on the surface of Earth too. It is in streams, rivers, ponds, and lakes. It helps people in many important ways. Rivers carry nutrients and spread them over the land as they flow. As a result, most land near rivers is rich and fertile, which means it is very good for growing plants. Many farms are located near rivers for this reason. Of course, farmers also need to give their crops fresh water every day to keep them healthy. People also use fresh water for daily tasks, such as washing dishes and clothes, cleaning and bathing, and so on. Water is used in industry, for transportation, and just for playing and enjoyment. But the most important role of fresh water is to provide clean water for humans and animals to drink. Without fresh water, life on Earth could not exist as it does today.
Lecture, Part 2. Threats to Earth's fresh water supply. Using bullets and brackets to organize your notes. Page 59.
As you can see, people, plants, and animals need fresh water to survive. Unfortunately, there are many problems threatening Earth's freshwater supply today. Unsurprisingly, these problems are caused by humans. Land development for human purposes leads to the loss of our natural environment. I'm referring in particular to the construction of buildings, roads, and parking lots. When we cover the Earth with concrete, the land can no longer absorb water. In other words, concrete prevents water and nutrients from entering the ground. Land development projects, therefore, affect Earth's freshwater supply in a negative way. Pollution also affects our water supply. Pollution comes from many sources. Factories, human waste, and fertilizers are just a few examples. Air pollution mixes with the rain, which falls to Earth and then enters the water supply. The trash that people drop on the street may end up in a stream or river. Farmers use fertilizers to help their crops grow, but then these chemicals seep into the ground and into the water. Some water supplies on Earth can no longer be used because they have become so polluted. However, perhaps the biggest threat to our fresh water supply is overuse by humans. The total amount of water on Earth can never increase. In contrast, the number of people on Earth is increasing all the time. Every year, there are millions of new people on Earth, which means millions more people using and drinking water. An increase in population means a need for more food, which means more farming and more water for crops. People use more water every year, and this is causing problems all over the world. According to the World Water Council, more than 1 billion people do not have access to clean, safe water. Water is our most important natural resource. No human could live more than a few days without water. Therefore, we must protect our water supply. People must learn not to waste water. All countries around the world need to cooperate in order to stop pollution and use water more carefully. Only by making changes now can we protect Earth's fresh, clean water for the future.
Unit 2. Water on Earth. Chapter 4. Earth's Oceans. Getting started. Expressing likes and dislikes. Page 63. 1.
I'd say swimming is my favorite sport. I really enjoy it. It's great exercise, and I always feel so energized afterwards. As soon as the weather starts to get warm, I look forward to swimming.
2.
I'm crazy about fishing. I started fishing when I was in high school, and I've been fishing ever since. I love being near the water under a blue sky and waiting for a big fish to bite. It's great.
3.
My girlfriend loves snorkeling, but I don't really like it myself. The mask and snorkel are uncomfortable to wear. In my opinion, it is hard to breathe when I am snorkeling. Honestly, I'd rather go fishing.
4.
Windsurfing? I don't care for it. Windsurfing is very difficult for me. It looks like a lot of fun, but actually, it's hard work. No thank you.
5.
Sailing is wonderful. I love it. When the wind is good, you feel like you're flying over the ocean in a sailboat.
Interview 1. Adventure under the ocean. Retelling what you have heard. Page 66.
I know you love to dive, Edmund. How did you first get interested in diving?
Well, when I was younger, I wanted to be a marine biologist. I really wanted to study the ocean and learn all about life in the ocean. So I thought, maybe I should learn how to dive.
So, did you take a diving class?
First, I had to learn how to swim, because I wasn't a good swimmer. So I took a swimming class. Then when I was in high school, I got certified in scuba diving. I started diving then, and I've never stopped.
When you dive with your equipment, your tank, how long can you stay underwater?
Let's see. The longest I've stayed down is a little over 3 hours, but usually I'm down for just 45 minutes or so.
And why do you dive? Is it just for fun?
Yeah, for fun. I do it to relax, to see things, and I often see something or find something interesting.
Like what?
Okay, like the last thing I found were these really old bottles. Like, I found one bottle from the early 1900s. I was really surprised when I saw the date. I found some other bottles too, but that one was the oldest.
100 years old. That is surprising.
And then a few months ago, maybe, I was out diving, and a seahorse swam by. It's unusual to see that kind of fish, so I took a picture.
So you take photographs underwater too?
Yes, I always carry my camera. I like to show other people that I saw something. Because if I tell people, I saw a seahorse, they go, yeah, right.
What is it about diving that you like so much? I mean, why haven't you gotten bored with it after all these years?
Well, I think it's an adventure. It adds a lot to my life. I have all of these experiences, interesting experiences, that a lot of people don't have. Diving never feels boring to me.
And you said you do it to relax?
Yeah, to me, it's very peaceful. The ocean is very quiet and calm. You can just sit there and look at the fish. It's very relaxing.
So the ocean never feels threatening to you at all? Don't you sometimes feel scared?
No. Well, when I first started diving by myself, I used to always turn around to look for the shark that would come and get me. It never was there. So I guess you stop worrying about it. Although there were a couple times when I felt scared.
For example?
Well, a few times an eel has hit me while I was diving. The first time, I felt something hit my hand, and I looked down and saw something gray swimming around my chest, and then it swam away.
Wow.
And another time, I was swimming along, and I looked up and saw 2 huge fins, and I started panicking because the fins were bigger than me. So I was like, and then I told myself, okay, those are whales, calm down.
You swam into a whale?
I was swimming along next to one. And then I guess the whale heard me because it just started slowly rising up and went to the surface. When it did that, I could see that there was another whale, a baby.
Swimming with whales. Now that's a very special experience.
I went to the surface to look for them, but they swam away.
When you're down there, diving and swimming under the water, do you feel like you're part of the ocean environment?
I feel like a visitor, you know? Especially when the ocean pushes you around. Sometimes I can't get to where I want to go, so I have to go someplace else to look around.
You mean you can't always control where you want to go, and you have to follow the ocean?
Yes, exactly.
Interview 2. Surf's Up. Listening for main ideas. Page 67.
Hey, Tomoki. Let's start with some background questions. When did you first begin surfing and why?
I started surfing, I believe, about 5 years ago. I'd always been interested in the sport, and I finally started when one of my friends gave me a surfboard. Since I had my own surfboard, I just thought I'd give it a shot.
Did you love surfing right away?
Yeah, right away. Part of the reason is I've always loved the ocean. When I was a child, I remember that every summer I spent all my time at the beach playing in the water. So yeah, when I tried surfing, I couldn't even sit or stand up on the board, but I still liked it.
I've heard that it's pretty hard to stand up on a surfboard. Most people can't do it the first time they go surfing. Is that true?
It's challenging. It's not something you can do right away. You need to practice. Surfing is just like any other sport. You need to practice to be good at it.
Other than practice, what else do you need to be a good surfer?
Well, I think physically you need to be fit. That means your body has to be strong so that you can swim. And in order to stand up on the board, you need to have good balance. That's the physical part.
Is there anything else you need for good surfing?
Well, you need to have waves.
Obviously. And what about wind? Is wind good for surfing or not?
Not too good. Usually surfers hope that there's no wind.
But doesn't the wind bring the waves?
Yeah, but if there's too much wind, the surface of the ocean is not that clean. We say that the surface is choppy or clean. Surfers always want to have a clean surface.
Now, could you describe to a non-surfer what it feels like to surf?
Well, it feels like you're sliding over the wave, but the wave is always moving. It's very dynamic because everything is moving together.
Okay, I can imagine that.
It feels like you're flying through the water, and the shape of the wave is so beautiful. Sometimes you can see inside the ocean. You can actually look inside the wave and see fish and the ocean floor. How does it feel? It just feels good.
Do you feel that you're controlling your surfboard, or do you have to go where the wave takes you?
Both. You really feel the power of nature, the power of the waves in your whole body. The waves are moving your entire body through the ocean.
That's a lot of power.
And you need that power, but you also need to be able to control the movement of your board. There's nothing else like it. That's why I love surfing. It's unique.
Thinking critically about the topic. Page 67. Listen to the last part of the interview with Edmund.
When you're down there, diving and swimming under the water, do you feel like you're part of the ocean environment?
I feel like a visitor, you know? Especially when the ocean pushes you around. Sometimes I can't get to where I want to go, so I have to go someplace else to look around.
You mean you can't always control where you want to go, and you have to follow the ocean?
Yes, exactly.
Now, listen to the last part of the interview with Tomoki.
Do you feel that you're controlling your surfboard, or do you have to go where the wave takes you?
Both. You really feel the power of nature, the power of the waves in your whole body. The waves are moving your entire body through the ocean.
That's a lot of power.
And you need that power, but you also need to be able to control the movement of your board. There's nothing else like it. That's why I love surfing. It's unique.
Lecture. Glenn Jackson. One World Ocean. Before the lecture, listening for signal words and phrases. Page 72. 1.
Some people say that there is one more ocean called the Southern Ocean, down near the Antarctic continent. However, not all scientists agree that the Southern Ocean is a separate ocean basin.
2.
The sun heats the seawater in this upper layer. Therefore, the surface layer is sometimes called the sunlit zone.
3.
The biggest difference between the surface layer and the middle layer is the temperature of the water. As I just said, the surface layer is relatively warm, with an average temperature of 17 degrees Celsius.
4.
Sunlight becomes much weaker below the sunlit zone, so no plants can grow in the middle layer. Consequently, most of the animals living in this layer have to swim up to the surface layer to find food.
5.
The animals that live here have to adapt to be able to live in this cold and dark environment. For example, many fish in the midnight zone do not have eyes.
Lecture, Part 1. The World's Oceans. Using handouts to help you take notes. Page 74.
The topic of our lecture today is Earth's oceans. The percentage of our planet that is covered by ocean water is actually very high. The planet is divided into two halves, the northern hemisphere, which is the top half of the Earth, and the southern hemisphere, or the bottom half. 80% of the southern hemisphere is ocean. As for the top half, 61% of the northern hemisphere is ocean. Less than the southern hemisphere, but still quite a bit. The result is that 71% of the planet's surface is ocean, and only 29% is land. Naturally, all of the oceans are connected, so we can think of it as one world ocean which is divided into four main ocean basins. These four basins are the Atlantic, the Pacific, the Indian, and the Arctic. First, we have the Atlantic Ocean, which stretches between Europe and Africa and the Americas. Next, the Pacific Ocean, which is the largest and deepest ocean. The Pacific stretches between the Americas and Asia. Moving south, we have the Indian Ocean, which is easy to remember because it surrounds the country of India. And then, in the northern regions of our planet, we also have the Arctic Ocean, which is the smallest and shallowest ocean. Some people say that there is one more ocean called the Southern Ocean, down near the Antarctic continent. However, not all scientists agree that the Southern Ocean is a separate ocean basin. Again, the oceans are not actually separated. They are all connected, and water is constantly mixing and moving from one ocean to the other. This is why we can think of all our planet's oceans as one world ocean. Earth's oceans are very, very deep. The average depth from the surface of the ocean down to the ocean floor is 4,200 meters. As one goes down from the surface, one finds a very interesting feature. The ocean has a layered structure. This is because seawater has different densities. Density has to do with heaviness, the quantity of matter in a particular space or area. In the next part of our lecture, I'd like to look in more detail at the ocean's layered structure.
Lecture, Part 2. The Layers of the Ocean. Using handouts to help you take notes. Page 76.
An interesting feature of the ocean is its layered structure. Let's talk about each of the three main layers one by one. The first layer is called the surface layer. The surface layer is the top 100 to 200 meters of the ocean. The sun heats the seawater in this upper layer. Therefore, the surface layer is sometimes called the sunlit zone. Its warmth and light permeate the surface layer, making it an ideal place for many forms of life. Most of the ocean's fish and other marine life are near the surface layer, where they can find a lot of algae and other plants to eat. Beneath the first 200 meters or so of the ocean, the surface layer ends and the middle layer begins. The middle ocean layer goes down to about 1,000 meters in depth. The biggest difference between the surface layer and the middle layer is the temperature of the water. As I just said, the surface layer is relatively warm, with an average temperature of 17 degrees Celsius. By contrast, in the middle layer, the temperature drops very quickly. With every meter you go down, the temperature becomes colder and colder. By 1,000 meters, the average temperature of the ocean water is only 4 degrees Celsius. Sunlight becomes much weaker below the sunlit zone, so no plants can grow in the middle layer. Consequently, most of the animals living in this layer have to swim up to the surface layer to find food. Below the middle layer of the ocean, there is the bottom layer, which is all the cold, dense water below 1,000 meters in depth. As you can imagine, there is no sunlight here at all, so the water is pitch black. As a result, this layer is sometimes called the midnight zone. It has very cold, almost freezing temperatures. The animals that live here have to adapt to be able to live in this cold and dark environment. For example, many fish in the midnight zone do not have eyes. Some animals here make and give off their own light. Much of the ocean's bottom layer hasn't been studied yet, So scientists still don't know a lot about this deep environment. So let's just review very quickly what we talked about today. We have 4 main oceans: the Atlantic, the Pacific, the Indian Ocean, and the Arctic Ocean. All of the oceans are connected, and as a result, we can describe them as one world ocean. The oceans are deep and have a layered structure. There's a surface layer, a middle layer, and a bottom layer. There's much, much more to say about the ocean. It's the last unexplored region on Earth.
Focusing on the conclusion. Page 77.
So let's just review very quickly what we talked about today. We have 4 main oceans: the Atlantic, the Pacific, the Indian Ocean, and the Arctic Ocean. All of the oceans are connected, and as a result, we can describe them as one world ocean. The oceans are deep and have a layered structure. There's a surface layer, a middle layer, and a bottom layer. There's much, much more to say about the ocean. It's the last unexplored region on Earth.
Unit 3. The air around us. Chapter 5. Earth's atmosphere. Getting started. Listening for background noise. Page 87. Listen. Where is the person in picture A? Listen. Where is the person in picture B? Listen. Where is the person in picture C? Listen. Where is the person in picture D? Listening for background noise. Page 87. Listen. Why is the person in each picture having problems? Picture A.
It's so hot here. And humid, too. I'm going to need to take a shower because I'm sweating so much.
Picture B.
I should have stayed at home today. There is so much pollen in the air, and my allergies are so bad. I can't stop sneezing.
Picture C.
Oh, it's difficult to breathe up here. The air is so thin. I can't get enough oxygen into my lungs.
Picture D.
Oh boy, the traffic's bad today. Ugh, the air feels really dirty. Oh, I hope I don't get sick.
Interview 1. Pollutants in the air. Listening for specific information. Page 90.
Jeff, you work for an environmental organization, is that right?
Yes, that's right. I'm the director of an organization that tries to protect our natural environment in many different ways.
And one of the ways your group helps the environment is by protecting air quality?
Right. We're always thinking about air quality and its effects on people and nature.
What are some factors that affect air quality?
Well, there are a number of factors that affect air quality. First, there are a lot of pollutants in the air.
Interview 1. Pollutants in the air. Listening for specific information. Page 90.
Jeff, you work for an environmental organization, is that right?
Yes, that's right. I'm the director of an organization that tries to protect our natural environment in many different ways.
And one of the ways your group helps the environment is by protecting air quality?
Right. We're always thinking about air quality and its effects on people and nature.
What are some factors that affect air quality?
Well, there are a number of factors that affect air quality. First, there are a lot of pollutants in the air, and many of these pollutants come from human activities, meaning things that people are doing or making.
Can you give some examples of pollutants made by humans?
Well, the most common human-made pollutants that you see come from burning fuels. For example, when factories burn oil, natural gas, or coal, this creates pollutants that go into the air.
And cars, right? I think that's the example that most people think of.
Cars create a number of pollutants in the air. Have you ever heard of particulate matter? Particulate matter is tiny pieces of matter that are small enough to float in the air. Cars make a lot of particulate matter.
Can you see particulate matter in the air?
Well, you can when there's enough of it. In fact, if you look at a factory, sometimes you can see a dark cloud coming out of it.
Oh, I know what you mean. That big cloud of smoke that comes out of the top of the building.
That's the particulate matter. Some of it falls on the ground. You know, if you're in an area with many factories, you might see a black or gray coating on cars or on the ground. That's the particulate matter.
That's terrible.
But some particulate matter is so small, very small particles, you can't see it at all.
So people don't notice when they breathe it in?
Usually not. But even though we can't feel it, it can cause damage to our lungs.
We've talked a lot about particulate matter that is made by humans. Are there any natural sources of particulate matter?
Natural sources, well, one is wildfire that starts naturally from lightning or something like that. When a wildfire burns, it sends a lot of particulate matter into the air. Similarly, a windstorm, like in the desert, blows pieces of soil into the air. So, wildfire, windstorms, these are a couple of examples of natural sources.
Interview 2. Air quality. Listening for specific information. Page 91.
Shari, you live in a big city. Tell me about the air quality there.
Well, it can be bad, especially in the summertime. There are mountains near my home, but you can't even see the mountains at certain times of the year because the air is so bad.
By bad, you mean polluted? Dirty?
Dirty and polluted.
What does it actually look like when the air quality is bad?
It looks hazy. It's like fog, but it's brown like smoke, and that's why they call it smog. Smog comes from the word smoke and fog mixed together. You get smog. So anyway, the air just looks hazy, but it's brown.
When the air quality is bad, does it affect you physically?
Sure. When there is a lot of smog, I get really bad headaches. Sometimes my headaches are so bad I can hardly think, and it is difficult to breathe.
That sounds dangerous.
During the weather report, they always include a smog level advisory. It's basically a system to tell people if the air quality is good or bad. I think it's between 0 and 5, where 5 is dangerous and 0 is completely clear. Anytime it's over 3 or 4, they warn people to be careful.
So this advisory tells you how much smog is in the air.
Right, the amount of pollution. When I was in school, whenever the advisory was above 3 or 4, when we went to PE, we weren't allowed to exercise outside.
It's not safe to be outside?
When it reaches a certain level, the city decides that it's dangerous to exercise outdoors, so they tell people to stay indoors at these times.
Listening for specific information. Page 91.
It looks hazy. It's like fog, but it's brown like smoke, and that's why they call it smog. Smog comes from the word smoke and fog mixed together. You get smog. So anyway, the air just looks hazy, but it's brown.
When the air quality is bad, does it affect you physically?
Sure. When there is a lot of smog, I get really bad headaches. Sometimes my headaches are so bad I can hardly think, and it is difficult to breathe.
That sounds dangerous.
During the weather report, they always include a smog level advisory. It's basically a system to tell people if the air quality is good or bad. I think it's between 0 and 5, where 5 is dangerous and 0 is completely clear. Anytime it's over 3 or 4, they warn people to be careful.
So this advisory tells you how much smog is in the air.
Right, the amount of pollution. When I was in school, whenever the advisory was above 3 or 4, when we went to PE, we weren't allowed to exercise outside.
It's not safe to be outside?
When it reaches a certain level, the city decides that it's dangerous to exercise outdoors, so they tell people to stay indoors at these times.
Interview 3. Humid and dry air. Answering multiple choice questions. Page 93.
Kelly and Michael, thank you for talking to us about air today. Kelly, you live in a humid environment, and Michael, you lived in a very dry environment.
Yep.
Yes, I did.
Kelly, I know that you're a very athletic person. What sports do you like?
Well, I like hiking, running, volleyball. I also like basketball, and I especially love cycling.
Could you tell me how the air affects you as an athlete?
I think the most important factor for athletes is humidity.
The amount of water in the air?
Exactly. So if it's humid, if there's more water in the air, it can be very uncomfortable for athletes.
Why is that?
Because when you're playing sports, your body makes a lot of heat. You need to get rid of some of that heat by sweating.
I see. Sweating is important because it takes the heat out of our bodies. But how is that related to humidity?
Well, if it's humid, there's already a lot of water in the air, so the sweat stays on your skin and you still feel hot. But if the air is dry, the sweat can evaporate and cool your skin.
So when it's humid, it's harder to cool your body down?
Right. And you may feel more tired.
Michael, humidity was not a problem for you, right?
Not at all. I lived in a very dry place.
Did you live in the desert?
Yes. For a short time, I was living in the desert near Mexico. They only get 2 to 3 inches of rain in a year, so it's very, very dry.
And hot?
Yep. It's one of the hottest places in the world, actually. One day, I remember, it was very hot and dry, and the wind blew up a dust storm.
What was that like?
Well, it was like fog. I couldn't really see anything. I was driving with my friends, and we stopped our car.
Did you get out of your car?
Just for a minute. The wind was blowing the sand all around us, just like in the movies. And it was so hot. We spent maybe 1 minute outside the car, and then we said, "This is crazy. Let's get out of here."
Did living in the desert affect you physically?
It was difficult to get used to the strong heat. I had to drink a lot more than usual to make sure my body got enough water. In fact, I probably drank, a half gallon to a gallon of sports drinks a day.
How is the air quality?
Most of the time the air was very clean, but it did dry you out. I noticed that my lips and skin were dry all the time.
Was it hard to breathe the air?
Oh yes, when it was really hot and dry, you had to be careful not to exercise too much. It would almost hurt your lungs. You'd want to wait until it cooled down a bit in the evening.
Lecture. Ken Needham. What is in the air out there? Before the lecture. Identifying key vocabulary in the lecture. Page 97. 1.
The amount of water vapor in the air, in other words, the humidity level, is something I know you're all familiar with.
2.
Have you ever thought about the idea of solids in the air? The term particulate matter is defined as any tiny pieces of solids that are small enough to float in the air.
3.
Flowers, trees, plants, they release pollen, or a powder made by flowers, and other natural matter.
4.
Humans also add particulate matter to the air. Because of human actions, there are some substances in the air that shouldn't be there. Or there's too much of certain substances, and this is what we know as pollution.
Lecture. Part 1. Humidity. Organizing your notes in an outline. Page 99.
Take a deep breath. Have you ever thought about what you breathe in every time you take a breath? We can't see it, we can't feel it, but air is all around us. Because we can't see air, we often think that air is empty. But air actually contains many different things. So today, I'd like to talk about what's in the air out there. You probably know that air around you is composed of a lot of different gases. The two main gases that make up the air are nitrogen and oxygen. Nitrogen makes up 78%, and oxygen makes up 21% of the air we breathe. But there are also about 10 other gases that are in the air in very small amounts. And even though we can't see or smell or taste these gases, we could not live without them. The amount of water vapor in the air, in other words, the humidity level, is something I know you're all familiar with. If you hear on the news that today's humidity is 80 or 90%, that means there's a lot of water vapor in the air. If you are outdoors and it is hot and humid, your clothes will probably feel sticky and you'll probably feel uncomfortable. But if you hear that today's humidity is 50%, that means there's a lot less water in the air. 50% is comfortable for most people. Deserts and other dry places can have a humidity level of only 10%. Not much water in the air at all. When you're outside in 10% humidity, your mouth will probably feel dry and you'll need to drink something soon. Before we move on, let's talk about how water vapor gets into the air. Now, the most obvious source is rain, snow, and other forms of liquid or solid water that falls from the clouds. Sometimes the rain or snow changes to vapor as it falls, and it stays in the air. But water vapor can also enter the air from sources on Earth, from oceans and rivers, from trees and plants, and even from the ground.
Lecture. Part 2. Particulate matter. Organizing your notes in a chart. Page 101.
So far, we've talked about gases and water vapor in the air. Have you ever thought about the idea of solids in the air? The term particulate matter is defined as any tiny pieces of solids that are small enough to float in the air. Now, these tiny pieces of matter are so small that they're carried in the air and they're too light to fall to the ground. There are many different kinds of particulate matter. Some are found in the air naturally, and others are human-made. That is, they're the result of human activity. I'd like to talk about a couple of different types of particulate matter. Let's start with particulate matter that occurs naturally. When a volcano erupts, it shoots smoke and ash into the air. In the same way, a forest fire fills the air up with smoke. When the ocean waves crash against the shore, salt and sand fly into the air. Flowers, trees, plants, they release pollen, or a powder made by flowers, and other natural matter. Have you ever walked through a field and then started sneezing? That might be pollen in the air entering your nose. Dirt and dust from the environment may be picked up by the wind, then fly into our eyes and make them red and itchy. All of these are examples of naturally occurring particulate matter that is found in the air. Humans also add particulate matter to the air. Because of human actions, there are some substances in the air that shouldn't be there. Or there's too much of certain substances, and this is what we know as pollution. When humans burn wood for cooking and heating, or they burn plants or trees, they add particulate matter to the air. When humans cut down trees and take water from the land, it's easier for dirt and dust to be picked up and carried in the air. But the activity that creates the most pollution is the burning of coal and other fossil fuels. This means every time we use fuel to power a factory or run a car, pollution is added to the air we breathe. When we breathe these particles in, they can hurt our eyes, our throats, and our noses, or cause more serious health problems. Let me just remind you, the next time you look around at all that empty air, there really is a lot out there.
Unit 3. The Air Around Us. Chapter 6. Weather and Climate. Getting Started. Listening for Specific Information. Page 104. 1.
It's going to be a beautiful day today. We're looking at a clear sky, no clouds, and warm temperatures. Be sure to get outside and enjoy the weather.
2.
You may want to leave work early this afternoon, everyone. It's already very cloudy out there, and we have some strong wind. The thunderstorm will be here in about an hour. Be careful driving.
3.
It's getting colder and colder. It has been raining all morning, but soon that rain will change to snow. It looks like temperatures are going to get even colder tonight, so be prepared for a lot of snow tomorrow morning.
4.
The good news is the heavy rain has ended. The bad news is we're still going to have a lot of fog today, but it's definitely better than yesterday.
Interview 1. A future meteorologist. Listening for specific information. Page 106.
Sarah, tell me a little bit about yourself.
Okay. I'm from Portugal, and right now I'm a graduate student. I'm studying meteorology.
Could you explain what meteorology is?
Well, meteorology is the study of our planet's atmosphere. It is a way of describing and trying to understand what happens in the atmosphere.
How did you become interested in meteorology?
It's funny. When I was a teenager, I couldn't decide what I wanted to be. My father always told me science is a good subject to study. He said, "Science is very good. Scientists can do many things." I guess he influenced me because I chose science as my major.
So your father influenced your decision to study meteorology?
Yes, and another reason is I've always had a fascination with the sky. When I was young, I would stare at the sky, looking at the clouds and watching them pass.
You like to watch the clouds?
I wanted to know why one cloud is different from another one. And one day, when I was around 17 years old, I told my mother, "Why don't I study meteorology? I like the sky."
Are you happy that you chose meteorology as your major?
Yes, very happy. Our atmosphere is so important. People don't realize. I think because we can't see air, we think the air is nothing. But that's not true.
Of course not. We all need air to survive.
Think of it this way. Earth is like a big aquarium. We are just like fish who live in the aquarium. And our atmosphere is just like water. Fish need water to survive, and we need air. Without the atmosphere, all human beings on Earth would die.
Listening for specific information. Page 106.
Our atmosphere is so important. People don't realize. I think because we can't see air, we think the air is nothing. But that's not true.
Of course not. We all need air to survive.
Think of it this way. Earth is like a big aquarium. We are just like fish who live in the aquarium. And our atmosphere is just like water. Fish need water to survive, and we need air. Without the atmosphere, all human beings on Earth would die.
Interview 2. Severe weather. Predicting the content. Page 107. 1.
Dorothy, tell us about your experience.
Well, I was in a blizzard last October. It really was a freak storm. I mean, generally we don't get much snow in New York in October, but this was a lot of snow.
2.
Yukia, what kind of severe weather did you experience?
In my case, I was caught in a flood about 2 years ago.
3.
Evelyn, you were also in a dangerous situation.
That's right. When I was 16 years old, a hurricane struck my hometown.
Interview 2. Severe weather. Predicting the content. Page 108.
You've all had experiences with severe weather. Dorothy, tell us about your experience.
Well, I was in a blizzard last October. It really was a freak storm. I mean, generally we don't get much snow in New York in October, but this was a lot of snow.
Did the snow come quickly?
Yes, very quickly. The snow started falling on a Thursday, and it was falling very fast, and by Friday morning we had about 2 feet of it.
2 feet of snow?
The worst part was that it was very heavy, wet snow, and the weight of the snow brought down a lot of tree branches. And then, when the tree branches broke, they fell onto the power lines, and the power lines came down too.
Oh no! That means no electricity.
Right. After the blizzard, so many people were left without electricity. The power was off for 2 weeks, in some places even longer.
How about you? Did you lose power in your home?
Yes, but we were lucky. Our power came back on after 4 days.
Yukia, what kind of severe weather did you experience?
In my case, I was caught in a flood about 2 years ago.
A flood? So, you were caught in a lot of water.
A lot of water, caused by a lot of rain.
What do you remember about it?
I remember I was at school, studying, and at that time I was stressed out about my homework, And it was raining really hard, but I didn't pay much attention to it. Then, all of a sudden, the lights went out.
You lost power?
Yeah, no power. So I went outside, and when I opened the door, I saw all this water pouring into the parking lot.
Coming toward you?
Well, it was flooding into the parking lot. It looked like a big pool. But I had to get out of there, so I had to go through the water. First, it came up to my knees, and then it came up to my waist. I actually saw one car floating.
Was it still raining?
It was raining really hard, and all around me there was water and mud and tree branches and all kinds of broken things. It was crazy.
Were you scared?
Yes, I was scared, but at the same time, I was kind of excited. I'd never seen anything like that before. I was like, this is definitely going to be on the news.
Did you get out of the flood safely?
Yes, I finally got out and I went home. I was fine, just, I was soaking wet.
Evelyn, you were also in a dangerous situation.
That's right. When I was 16 years old, a hurricane struck my hometown.
And this was a very powerful hurricane?
It was a Category 4 hurricane, so one of the strongest hurricanes to ever hit the United States.
Do you remember what it was like when the hurricane hit your hometown?
I remember when the hurricane hit, it was amazing. Houses right across the street from me were torn apart. Trees were pulled out of the ground and thrown down the street.
Wow. The wind was pulling the trees out of the ground?
Yeah, trees and lampposts were flying everywhere.
Scary.
Yes, it was scary. But I also thought it was kind of fun. I guess that sounds strange, but I was pretty young at the time, so it was exciting. Of course, I was worried about the families in the houses that were destroyed.
Was your house damaged?
No, my house wasn't damaged badly. We were lucky. But after the hurricane, the whole town didn't have power for a couple of months.
What a terrible experience.
But I learned a lot from that experience. Now I know if there's ever a warning about a natural disaster, I need to take it seriously. Once you experience something like that, you remember it for the rest of your life.
Listening for opinions. Page 108.
I'd like to ask you about global warming. Sarah, you're a meteorology student. Do you think global warming is affecting our weather on Earth?
Well, my opinion is global warming is really happening, and everybody knows that. And everybody knows that human beings are a little bit responsible for it. But as for the weather, there are some changes that I think are natural. Changes that would probably happen even without people.
So, in your opinion, global warming is not affecting our weather?
I don't know. With science, until you have the right answer, you can't say for sure. I can't say for sure if global warming is affecting our weather or not.
Dorothy, do you think global warming is affecting our weather?
Personally, I do. Just look at the weather these days. Hurricanes are becoming stronger and more severe. I don't think it's just the natural cycle of things.
And do you think the cause is global warming?
Yes, I can see how the weather has changed just in my hometown. The winters used to be longer and colder, and now they're warmer and there isn't as much snow.
Yukiya?
I agree with Dorothy. I'm not a scientist or anything, but I've heard that global warming is melting the ice in Antarctica. And the water level of our oceans is going up, and that's what causes the hurricanes. I'm sure global warming is having some effect on the weather.
Evelyn?
I agree. I think global warming is making the weather worse, and there's more risk of dangerous weather. Because humans are changing Earth, that's causing the weather to change. We need to start doing some things soon to protect our environment, or it's all going to be gone.
Lecture. Fred Mackenzie. Global warming. Before the lecture. Listening for numerical information. Page 112. 1.
Since the beginning of Earth, about 4.6 billion years ago, there's been a mixture of gases surrounding the planet.
2.
Now, the atmosphere acts as a kind of a shield and a filter. It reflects about 30% of the sun's energy back into space. About 70% of it actually passes through the atmosphere. Of that 70%, much of it is absorbed by the clouds and air. Only half of the energy that passes through the atmosphere, about 35%, reaches the Earth's surface, which is warmed by the sun's energy.
3.
This has led to a heating of Earth's surface. In the past 100 years, scientists have found an increase of 1 degree centigrade in the average temperature on Earth.
4.
But unless we change the way we do things today, which means we must stop relying on fossil fuels for 80% of our energy supply, the amount of greenhouse gases will continue to increase and temperatures will continue to go up.
Lecture, Part 1. The Greenhouse Effect. Copying a lecturer's illustrations. Page 113.
Well, the topic of my lecture today is global warming. But before I talk about that, I'm going to give you some background information about Earth's atmosphere. As you already know, the atmosphere is what we call the layer of gases that surrounds the planet. Since the beginning of Earth, about 4.6 billion years ago, there's been a mixture of gases surrounding the planet. Now, some of these gases are called greenhouse gases. We call them greenhouse gases because they create a greenhouse effect. That is, they make the atmosphere warmer because they absorb heat from the sun. Well, let's look more closely at the interactions that lead to the greenhouse effect. Energy from the sun is the force behind our climate systems. It approaches Earth and enters the outer layers of our atmosphere. Now, the atmosphere acts as a kind of a shield and a filter. It reflects about 30% of the sun's energy back into space. About 70% of it actually passes through the atmosphere. Of that 70%, much of it is absorbed by the clouds and air. Only half of the energy that passes through the atmosphere, about 35%, reaches the Earth's surface, which is warmed by the sun's energy. The Earth emits or sends this energy back towards the atmosphere. About 10% of it leaks back into space, but most of the heat stays inside our atmosphere. This process helps to maintain global temperatures within certain limits. It's called a greenhouse effect because warmth is sealed inside, just like in a greenhouse. We've always had greenhouse gases in our atmosphere, and we've always had a natural greenhouse effect on this planet. But what has happened in the past century or so is that human activities have added more greenhouse gases to the atmosphere. As a result, the greenhouse effect has become stronger. With more greenhouse gases in the atmosphere, more energy from Earth is absorbed. This has led to a heating of Earth's surface. In the past 100 years, scientists have found an increase of 1 degree centigrade in the average temperature on Earth. While there has been some debate, I think people have realized that the increased greenhouse effect is causing the problem of global warming.
Lecture, Part 2. Effects of Global Warming. Listening for Cause and Effect. Page 115.
An increase of 1 degree centigrade in Earth's temperature may not seem like a lot, but it actually causes many changes on our planet. What are the consequences of this increase in Earth's temperature? Today, I'd like to focus on 2 effects of global warming. The first is an increase in sea level. The sea level has risen over the past 100 years between about 15 and 25 centimeters. It is rising now and will continue to rise in the future. Some of this rise is due to the heating of the ocean surface. When ocean waters warm, they expand or get bigger, and so the sea level rises. Another cause is melting ice and snow. The meltwater is entering the ocean and resulting in a rise in sea level. Changes in the weather are another consequence of global warming. As Earth's temperatures continue to rise, some areas of the world will become wetter and some will become drier. Already, many countries around the world are experiencing more and longer periods of drought. In other words, long periods of time without enough rain. In fact, the amount of land affected by drought has doubled since the 1970s. Another example of weather change is an increase in severe storm activity. Some scientists believe that if global warming continues, we will have more hurricanes. Hurricanes develop over warm oceans, and so the rise in ocean temperatures may cause more and perhaps stronger hurricanes. Today I told you about just two effects of global warming: a rise in sea level and changes in the weather. There are many other consequences of global warming. It's difficult to predict the future. But unless we change the way we do things today, which means we must stop relying on fossil fuels for 80% of our energy supply, the amount of greenhouse gases will continue to increase and temperatures will continue to go up. Scientists predict that this century, temperatures will rise to about 3 degrees centigrade higher than they are now. Sea levels are also likely to go higher, about 60 centimeters above their current level. So, global warming is a real problem for all of us. It may be the most serious problem in our world today. And I think all of us, as individuals, must take action to solve this problem.
Unit 4, Life on Earth. Chapter 7, Plants and Animals. Getting started. Listening for specific information. Page 127. 1.
The blue whale is the largest animal in the world. Many scientists think that the blue whale is the largest animal that has ever existed on Earth. It can grow up to 33 meters long and weigh as much as 150 tons. Its heart is the same size as a small car. The blue whale's natural habitat is the deepest waters of all the world's oceans.
2.
The Venus flytrap is a very unusual plant because it is a plant that eats meat. The Venus flytrap catches insects in its leaves and then eats them. This plant's natural habitat is in the United States, but now it grows all over the world.
3.
The platypus is a very unusual animal. It has a bill and webbed feet like a duck, but it has a wide, flat tail. It lives on land, but is a very good swimmer. The platypus lives only in Australia.
4.
Trees are the biggest plants in the world. The largest type of tree on Earth is the giant sequoia. The natural habitat of the giant sequoia is the mountains of California. These trees can grow to be more than 100 meters tall.
5.
Almost half of all insects on Earth are beetles. Scientists have already found 350,000 different kinds of beetles. They can live everywhere, except for the ocean and cold polar regions. The beetle, pictured here, is the Goliath beetle, the largest and heaviest insect on Earth.
6.
Many people think that bamboo is a kind of tree, but actually, bamboo is a type of grass. Bamboo is the fastest growing plant on Earth. It can grow 4 centimeters in just 1 hour. Bamboo can be found in many different habitats, from cold mountains to hot tropical jungles.
Interview 1. A green thumb. Listening for specific information. Page 129.
Frank, your hobby is gardening, right? How did you get started?
Well, let me take you back a long, long time. When I was a kid, everybody had gardens. Wherever we could find a little space, we'd plant some vegetables, like tomatoes or something like that.
Did you grow vegetables because you could eat them?
We didn't have a lot of money back then, so yes, we planted and grew things we could eat. And so, because I grew up in that situation, I was always interested in planting and growing things. These days, I enjoy growing native plants.
What does that mean, native plants?
Native plants are plants that are originally from the area in which they are found. So I like to look for and collect plants that grow in my neighborhood.
What got you interested in native plants?
Well, one of the reasons is to collect native plants, I have to go to places where other people don't go. I don't like to go where lots of other people have already been. I like to get off the trail.
So you like the challenge of finding and collecting the plants?
Yes, and there's something else I like too. I like to share with other people who are also interested in native plants.
Vicky, how about you? What attracted you to gardening?
Well, when I was young, everyone was trying to be more green and natural and grow their own food. I tried it too and found out I was good at growing plants. I just kind of had a knack for it.
What sort of plants were you growing?
When I started, I only had a small apartment, so I was growing houseplants. I also had a few tomato plants and some herbs.
Okay.
And then, when I bought a house, I started to do more gardening outside. Now what I do is mostly perennials. That's really my love now, the perennials.
Can you explain what a perennial is?
Well, basically there are two kinds of plants, annuals and perennials. Perennials are plants that come back year after year.
Oh, that makes sense, because perennial means for a long time.
Annuals are the ones that die in the winter, and they don't come back. Perennials look like they die in the fall, but they've really just become inactive. They come back up again in the spring, and that's what I find so exciting. Most perennials go through that cycle for years and years. Some plants even live longer than humans. You plant them, and your grandchildren will have the same plants. I really like that.
You said that you have a knack for growing plants. Why is that? What makes your plants grow better?
You know the expression having a green thumb? I guess that's what I have. But I think it's just an ability to notice little differences.
Differences in the plants?
The plants and their environment. You see a plant that's doing well in an environment, so you try to continue the same kind of care. If you have a plant that's not doing well, you have to find out, is there too much sun? Is there not enough sun? Is there enough water? Is there too much water?
I see. Vicky, is it true that gardening makes people feel calm and relaxed?
Well, it's true for me. I go out to my garden and I get right down, put my hands into the dirt, smell the plants, and I can forget about my day-to-day troubles. When I'm in the garden, I don't think about my worries and responsibilities. I feel very connected to the earth, very relaxed and focused. And so for me, it's very calming.
Lecture. John Norris. What is a living thing? Before the lecture. Listening for expressions of contrast. Page 136. 1.
Plants, for example, grow taller and wider throughout their lives. Animals start growing as soon as they're born. Unlike plants, however, they usually stop growing when they become adults.
2.
I'm sure you can think of many examples of different kinds of animal movement. Walking, flying, swimming. Plants move too, but not in the same way as animals.
3.
Plants have a very special way of getting food. They make it themselves. To make their own food, plants take a gas called carbon dioxide out of the air. They combine the carbon dioxide with water and sunlight to make food. This food is stored inside the plant and used when the plant needs energy. Animals, on the other hand, cannot make their own food.
4.
The process of respiration helps to change the food into energy. Now, animals take in oxygen by breathing in the air, whereas plants take in oxygen through tiny holes in their leaves.
5.
During reproduction, plants and animals make more of their own kind. Animals have babies or lay eggs. In contrast, most plants make seeds which fall onto the soil and grow into new plants.
Lecture, Part 1. Growth, Movement, and Sensitivity. Checking your notes. Page 139.
Welcome to today's biology lecture, everyone. Biology is the study of all living things on our planet. But what do we mean when we say living thing? What does it mean to be alive? Well, scientists have a very clear way to answer that question. When scientists want to check if something is living or non-living, they look for 7 life processes, or 7 special actions that all living things must do. The 7 life processes are movement, reproduction, sensitivity, growth, nutrition, respiration, and excretion. These 7 actions are like a checklist. If something has all 7, it's a living thing. But even if one process is missing, then it cannot be called a living thing. As you can see, this checklist is very important to biologists. So in our lecture today, let's look at each life process in more detail. I'll start with 2 life processes that are easy to observe and understand: growth and movement. All living things grow, which means they increase in size. Plants, for example, grow taller and wider throughout their lives. Animals start growing as soon as they're born. Unlike plants, however, they usually stop growing when they become adults. All living things also move. I'm sure you can think of many examples of different kinds of animal movement: walking, flying, swimming. Plants move too, but not in the same way as animals. Plants move their roots down into the earth and their leaves up towards the sky. Some flowers open in the morning and close at night. Of course, the movement of a plant is much slower than the movement of an animal. An interesting similarity between plants and animals is that they all move for the same reasons: to get food, to find a safe place to live, and to escape from danger. Let's move on to the 3rd life process on our checklist. This next process is called sensitivity. What that means is that living things notice their environment and respond to changes in their environment. Animals take in information about their environment by using their senses. In other words, they see, hear, smell, taste, and feel things around them. Plants also take in information about their environment. Although plants do not have as many senses as animals, they do notice changes in water and light. The sunflower got its name because it turns its flower to follow the sun all day long.
Lecture, Part 2. Nutrition, Respiration, Excretion, and Reproduction. Organizing your notes in a chart. Page 140.
The next 2 processes are nutrition and respiration. You've probably heard of nutrition before. That's the process of getting food, and all living things need food for energy. Plants have a very special way of getting food. They make it themselves. To make their own food, plants take a gas called carbon dioxide out of the air. They combine the carbon dioxide with water and sunlight to make food. This food is stored inside the plant and used when the plant needs energy. Animals, on the other hand, cannot make their own food. Because of this, they have to eat plants or eat other animals that have eaten plants. Okay, so Once food is inside a plant or animal, the next life process begins, respiration. And what is respiration? The process of respiration helps to change the food into energy. Now, animals take in oxygen by breathing in the air, whereas plants take in oxygen through tiny holes in their leaves. In other words, we see that both plants and animals need and use oxygen to change food into energy inside their bodies. All living things need energy to support all the other life processes. So, you can see why nutrition and respiration are so important. During respiration and the other life actions, plants and animals create waste materials. These are extra materials that a living thing doesn't need or want. If the waste isn't removed, it will become harmful. Plants pass waste through their leaves and through their roots. Animals move waste out of their bodies in their breath, sweat, urine, and excrement. To quickly review then, all living things grow, move, react, eat, respire, and excrete. All living things also grow old and finally die. So the final life process, reproduction, is necessary for life to continue into the future. During reproduction, plants and animals make more of their own kind. Animals have babies or lay eggs. In contrast, most plants make seeds which fall onto the soil and grow into new plants. All right, that's our checklist. For something to be called living, it must show all 7 life processes: movement, growth, sensitivity, nutrition, respiration, excretion, and reproduction. Usually, we can easily identify something as living, but remember, it must meet all 7 life processes. An automobile moves, an automobile can be sensitive, an automobile requires nutrition, like gas, and it excretes smoke. But is it alive?
Unit 4, Life on Earth. Chapter 8, Humans. Getting started. Listening to directions. Page 143. Task 1.
Look at the picture in your book. Put the palm of your right hand down on top of a desk or table. Keep your arm relaxed. Put your left hand on the upper part of your right arm. Now, press gently down on the table with your right palm. Use your left hand to feel the muscles in your upper arm. Now, place your right palm under the desk or table. Push your hand gently up against the table. Use your left hand to feel the muscles in your upper arm. Now, answer the question in your book.
Task 2.
Place your hands on your sides, just above your waist, so that you can feel your ribs. Notice how your ribs move out when you breathe in, then fall back down when you breathe out. When you hear the beep, count the number of breaths you take in 10 seconds. 1 in plus 1 out equals 1 breath. Try to breathe naturally, without changing or controlling your breathing rate. Are you ready? Okay, start. Stop. Write the number of breaths you took in your book. Multiply that number by 6. This is your average breathing rate per minute.
Task 3.
Find the pulse on the inside of your wrist. Place your first 2 fingers on your pulse point, as shown in the picture. Try to relax and let your fingers rest lightly on your wrist. When you hear the beep, count the number of beats you feel in 10 seconds. Are you ready? Okay, start. Stop. Write the number of beats you counted in your book. Multiply that number by 6. This is your average heartbeat rate.
Interview 1. Running track. Listening for main ideas. Page 147.
Becca, you were an athlete when you were a student, is that right?
Yes, I was on the track and field team in college.
What kinds of training did you do?
The training, well, the coaches really break it down into steps. So the first step was a lot of weightlifting, like good, strong weightlifting. Then the next step was cardiovascular training.
Did you say cardiovascular training? What does that mean exactly? Training to help you breathe better?
Breathe better, yes, but also to make your heart stronger and to make your whole cardiovascular system work more efficiently.
And what kinds of exercises did you do for cardiovascular training?
Well, first, we would get a good warm-up, with a 3 to 5 mile run. After that, we did drills. With drills, you practice running form. That is, the best positions for your body when running. You practice the drills over and over again until your body remembers the positions.
Long runs, drills, anything else?
Next came the track workouts.
And that's running around a track?
Yes, these are shorter distances, but faster and with breaks in between. The coach would have us run really hard for a minute, then take a break for 5 minutes until we were fully rested, and then go right back into sprinting for another minute.
Can you explain how all of these different exercises helped your body?
Well, the long-distance running, that's really good for cardiovascular training because you're running at a slower pace but for a long time, so you build up your lungs and heart. And sprinting, the fast, short running, is good for strengthening your muscles.
So really, the muscles and the cardiovascular system are closely related.
Very closely, especially because when you're running, your muscles need oxygen so that they can work. When you run, you start breathing faster and harder, right? That's because your muscles need more oxygen. So you breathe in more air, and the oxygen goes into your lungs, your blood, and your muscles. So the cardiovascular system and the muscular system are very closely connected.
It sounds like running is a really good sport to make your body stronger and healthier.
Definitely.
Interview 2. Eat to live, don't live to eat. Listening for specific information. Page 149.
Louise, you're a registered dietitian. Why is good nutrition so important?
You need to eat to live, basically.
It's the basic idea, but people don't think about that.
Because I think more people, instead of eating to live, they live to eat. In our society, so many activities are centered around food. You have a special event and you go out for dinner. It's a holiday, so you buy some candy. A lot of our social events are centered around food, and I think that's part of the problem.
What's a healthier way to think about food? How can people remember that we need to eat to live?
Just think of what your body really needs. There are some basic food groups that people should eat every day, such as grains, vegetables, fruits, and certain kinds of fats.
We should eat fat every day?
Good fats. Also, fiber and vitamins and minerals. Those 6 nutrients are your body's basic needs.
So as long as we eat all of those things every day, we'll have a healthy diet?
Right. And, of course, you have to be careful of how much you eat. You don't want to eat too much of any one thing.
Can you explain how these different food groups help the human body?
Yes, absolutely. Let's start with fiber. I talk to my patients about fiber because fiber can help lower your cholesterol. If you have fiber in your diet and you also have some cholesterol in your body, the fiber can actually pull the cholesterol out of your blood.
So that's good?
Yes, it's good. I should point out that cholesterol is a natural part of our cells. You can't get rid of cholesterol. But there's good cholesterol, which isn't a problem, and bad cholesterol. Bad cholesterol is what clogs our blood vessels.
Now, how about protein?
Yes, you need protein. Protein has a lot of different functions, but mostly you need protein for your body to grow and to build muscles. That's the main role, to build and repair our muscles.
Protein for strong muscles. Got it. And carbohydrates and fats?
Those are your energy sources. We need a lot of energy every day, so that's why carbs are so important. And I know people think fats are bad, but you need fats to help protect your organs and to provide energy too.
Are there foods you can eat to build strong bones?
For bones, you should look at calcium and vitamin D. Those go hand in hand. You always hear about calcium because that's basically what makes your bones. But you need vitamin D to absorb the calcium from food.
It sounds like you can't eat only one kind of food. You need to have a mix of many different kinds of food.
Exactly. And to be healthy, you have to have good eating habits and also exercise. I cannot stress that enough.
Louise, I feel like there is so much need for this type of information right now. I'm just thinking of all of the problems that Americans are having with diet and nutrition.
I really enjoy helping people with the little things that can help them in their everyday life. Eat breakfast, drink water, cut back on coffee. Small, easy steps that people can see making a difference. That's empowering.
Lecture, Anthony Modesto, Systems of the Human Body. Before the lecture. Listening for expressions of time order. Page 153. 1.
This phase can last for several hours, and when it's over, the food has become a thick soup.
2.
From the stomach, it then moves into the small intestine where something very important happens.
3.
After taking all of the nutrients out of the food, the body doesn't need the leftover food anymore.
4.
When we breathe, air enters our body through our mouth and nose. Next, it travels through an airway into our lungs.
5.
Finally, the blood returns to the heart, ready to begin the cycle all over again.
Lecture, Part 1. The Digestive System. Taking notes in a flowchart. Page 155.
Have you ever thought about all the things that happen inside your body? The human body, like all living organisms, has many different systems, which is the topic of our lecture today. A body system is defined as a group of organs that work together to carry out a very specific function. Humans have 11 different body systems. These systems carry out every function necessary for life. When your body is healthy, the systems work together very smoothly. But if even one of the systems breaks down, you'd be in big trouble. You wouldn't be able to survive. Today, I'd like to focus on 3 of the 11 human body systems: the digestive system, the cardiovascular system, and the respiratory system. These 3 systems each have their own role in the body, but they also work together in very important ways. Together, they bring oxygen and nutrients to every part of the body. Of course, humans need oxygen and nutrients to live, so our digestive, cardiovascular, and respiratory systems are really important. Okay, where should I start? We all like to eat, so maybe I'll start with the digestive system. Our bodies use the energy in the food we eat to carry out all of our daily life functions. To get the energy from food, our body has to break it down and take the nutrients out of it. This process is called digestion. Digestion begins as soon as you put food into your mouth. As your mouth moves and chews the food, it becomes softer and breaks apart into smaller pieces. When the pieces of food are small and soft enough to swallow, they travel from your mouth down to your stomach. There in the stomach, powerful muscles squeeze the food and mix it together with chemicals. This phase can last for several hours, and when it's over, the food has become a thick soup. From the stomach, it then moves into the small intestine where something very important happens. Nutrients from the food pass through the intestine and move into the blood. Those nutrients have now become part of the cardiovascular system, which I'll talk about next. We're not quite done with digestion. There's one more step. After taking all of the nutrients out of the food, the body doesn't need the leftover food anymore. This waste moves into the large intestine and finally out of the body. The whole process of digestion from mouth to large intestine takes about 24 hours to complete.
Lecture, Part 2, The Respiratory and Cardiovascular Systems. Taking notes in a flowchart. Page 157.
Another important system is the respiratory system. Now, the job of this system is to bring oxygen from the air into the body. When we breathe, air enters our body through our mouth and nose. Next, it travels through an airway into our lungs. The air that enters our lungs is rich with oxygen. Inside the lungs, all of this oxygen passes into our blood. Like food, oxygen is necessary for life. Our body uses oxygen to carry out all of its life functions. We need to breathe about 8 liters of air every minute to stay alive, and even more when we exercise. Without oxygen, we would die in just a few minutes. By now, you've probably figured out that blood has many important roles in the human body. It brings nutrients from food and oxygen from the air to every part of our body. Blood is part of the cardiovascular system, and that's what I want to talk about next. The cardiovascular system is made up of 3 things: our blood vessels, and the heart. The heart is the source of power in the cardiovascular system. With every beat, the heart pushes blood in a cycle around the body, from the heart to the body, around the body, and finally, back to the heart again. When blood first leaves the heart, it's oxygenated, which just means that it's carrying a lot of oxygen. Vessels carry this oxygenated blood all over the body. One of the places the blood goes to is our small intestine. And do you remember what I said? What happens in the small intestine? That's where the blood picks up nutrients from food. As blood travels around the body, it gives oxygen and nutrients to each cell. When the oxygen in our blood has been used up, blood vessels carry it back to the heart. Then it's pumped into the lungs to get fresh oxygen from the respiratory system. Finally, the blood returns to the heart, ready to begin the cycle all over again. The entire cycle from heart to body and back to heart to lungs and back to heart again takes only 20 seconds. Well, that's a pretty simple overview, but I hope you can see how these 3 systems, digestive, respiratory, and cardiovascular, work together to maintain life. The digestive system brings nutrients into the body. The respiratory system brings oxygen into the body. The cardiovascular system carries nutrients and oxygen to the cells. Today we talked about only 3 of the body's 11 systems. When you consider that there are 8 other equally important systems, you can see that the human body is truly amazing.